So taking a look at the second half of our PowerPoint here, we're looking at how to sketch the graph of a rational function. And again, there's 6 steps, and they're exactly what they were in the last one. We walk you through how to do this one, but what I wanted to do is take a look at something more like this, as this is what your problems in Newton are most likely going to reflect. Okay, matching your graph with, or matching your equation with the proper graph. So what I wanted to focus on was which one of these is going to be the correct answer. Okay. Now, if you notice in step 1, we have to find the domain. The domain of our function is going to be all x's except x equal -1. In other words, there is a vertical asymptote at x equal -1. Got the hiccups for some reason, so y'all please pardon me. So when we look at this, you'll notice that I have a vertical asymptote in A at -1, in B at -1, and in C at -1. So vertical asymptotes everywhere. I can't really eliminate an answer yet. If we go in and take a look at step 2, sorry I kept going back and forth, I'm going to plug in 0 for x. Okay, so if I plug in 0 for x, I'm trying to find the y-intercept. And I get 0 over 0 plus 1, or 0. So C, B, and A are all possible answers. Again, I've not been able to eliminate any choices just yet. If we look at C, now we can start to try to figure out what's going on here. I want to figure out what happens if I go way far to the right, and what happens as I go way far to the left. Okay, well, I'm using the rules for horizontal asymptotes, and in those rules we look at the degree of the numerator and the degree of the denominator, and in this case both degrees are 1. So this tells me that the horizontal asymptote is the ratio of leading coefficients. In other words, the leading coefficient here is 1, the leading coefficient here is 1. So my horizontal asymptote is y equal 1. Okay. Well, that rules out choice A because it doesn't have a horizontal asymptote. And it rules out choice C because this horizontal asymptote is at -1 when it should be at +1. So we really didn't do any calculus in this problem per se, but we did walk through those steps to try to create the graph that we're looking for. Here's one that's a little different. We've got 4 minus x squared, and we have x squared right here. So you'll notice, again, we have some points of discontinuity. If you factor this, you get 4 minus x, 2 minus x, and 2 plus x. 2 minus x, 2 plus x. So if I'm wise, I'll figure out that I have vertical asymptotes at 2 and -2. And it looks like all of these have vertical asymptotes at 2 and -2. So I haven't helped myself much at all. Let's keep going. I want to find out what f of 0 is. So I'm going to plug in 0 for x. And when I do, I get 0 over 4, or 0. And again, I really haven't helped myself because all of these have places where the y value is 0. I could set this thing equal to 0, but I'm still only going to be looking at an x value of 0 and a y value of 0. So setting it equal, finding the x-intercepts doesn't really help me much. Let's look at the end behavior. So the degree of the numerator is 2, the degree of the denominator is 2, and our leading coefficient here is 1. On the bottom, our leading coefficient is -1. So what this tells me is the horizontal asymptote is y equal -1. Well, A looks like it might fit that bill. B does not, and C certainly does not. So I have again identified what the graph is based on the horizontal asymptote, and I haven't done any real calculus yet. So here's a problem we're not going to look at, those with where we have a cusp in them. We're really just focusing on these rational equations and these polynomials. So I would invite you to go in, take a look at Newton, See how you do. Give me some feedback, and I'll be glad to work with you on additional resources if you need those.